Okay, I think we're ready to get started here. Welcome everyone. Good morning. Thank you for joining us today for today's webinar. My name is Lori Jerome, and I am the Marketing Manager for Big Sky Installations and Premier Building Systems. For over 65 years collectively, we have been the leading manufacturers of structural insulated panels, otherwise known as SIPs. Recently, the two companies have combined their technical knowledge and best practices, and together, we are the largest SIP manufacturer in North America. Today, we are presenting Designing with SIPs, an engineer's tips on project optimization, SIPs as a deferred submittal, with special guest Troy Lestico, project engineer from Eclipse Engineering. In this 1-hour presentation, Troy, along with Lauren Greschel from Big Sky R-Control and Jeff Beeson from Premier Building Systems, discuss the history and options for SIPs from an engineer's perspective. Topics discussed will include why engineers prefer SIPs over stick framing, including speed of construction, the upfront cost savings of labor and materials, the superior structural benefits, energy efficiency of the final structure, and sustainable benefits over time. Real-life projects and examples will be discussed for both commercial and residential applications by experts from both an engineering and a manufacturing perspective. This is a live webinar approved by the American Institute of Architecture. A little housekeeping before we begin. We encourage your questions today, and we ask that you please type them in the Q&A section of your screen. We will be reviewing everyone's questions at the conclusion of the presentation. Our speakers are truly experts on SIP building and construction, and we encourage you to stick around for the Q&A if you have the time. If you're taking this class for AIA credit and you entered your AIA member number and certificate request during registration, your credits will be recorded with the AIA and a certificate will be sent to you within 2 weeks. You will also receive an email with a recording of today's presentation and a link to a survey to review today's course. We really appreciate it if you can provide your feedback and share your thoughts with us so we can continually create great content that you find informative and educational. Now, without further delay, I'm going to turn this over to our expert presenters.
Thank you, Lori, and welcome everybody. I'm Troy Lestico, and I'm a structural engineer based in Missoula, Montana with Eclipse Engineering. I've been a structural engineer for the last 26 years, and today I'm going to speak about our firm and our role on projects as structural engineers in a second. But first, let's hear from today's other presenters, Lauren and Jeff.
Hey all, Lauren Greschel here. I work with Big Sky R-Control. I've been working for them for over 5 years. I've got personal experience working with Troy and Eclipse Engineering. So it's an honor to have him on this call with us. And I'm located in Colorado. I manage a few different states for Big Sky Installations. And our third presenter is Jeff.
Hello, Jeff Beeson, located in Arizona, but I handle not only Arizona, but part of California, part of Nevada, selling SIPs. I've been doing it actually this past 21 years. And yeah, been doing it a long time, came from a construction and architectural background also, so thank you.
Thank you, Lauren and Jeff. Just a little information on structural engineering and Eclipse. Structural engineers, our role is to provide the structural design on your project, meaning that we produce the engineering calculations and ultimately the structural drawings for your project. Roof framing, floor framing, foundations, and the main lateral force resisting system to resist wind and seismic loads from earthquakes. We have 5 offices and 40 employees in the Pacific Northwest, including Whitefish in Missoula in Montana, Portland and Bend in Oregon, Spokane, Washington, as well as remote employees working in Texas, Missouri, Tennessee, and Oklahoma. We're licensed in 50 states and most of Canada, and we've completed drawings for billions of dollars of construction projects as the engineer of record in the residential sector, multifamily, light commercial, mid-rise commercial, educational, hospitality, religious, industrial, and specialty engineering projects such as timber frames, log homes, cross-laminated timber, and of course, structural insulated panels, which Lauren will talk about next.
Yeah, thanks, Troy. And, you know, Clips has a bunch of experience on board. And today we're going to be kind of going through a bunch of project profiles. I'm going to touch on a little bit of what a SIP is here initially, just to kind of get things rolling. And, but before I do that, we're going to read through a copyright page. This presentation is protected by US and international copyright laws. Reproduction, distribution, and display and use of this presentation without written permission of the speaker is prohibited. And Lori kind of mentioned this already, but I'm supposed to read this slide. Premier Building Systems and Big Sky Installations are registered providers with the American Institute of Architects, Continuing Education Systems. CES credits earned on completion of this program will be reported to the AIA for AIA members. Certificates of completion for both AIA members and non-AIA members are available upon request. This program is registered with the AIA for continuing professional education. As such, it does not include content that may be deemed or construed to be an approval or endorsement by the AIA of any material of construction or any method or manner of handling, using, distributing, or dealing in any material or products. So we'll handle questions at the end. And this session is, it will provide you with one AIA learning unit. So today we're gonna focus on, you know, structural engineering, accomplishing any design with SIPs by approaching the design with SIPs in mind. So working for a SIP manufacturer, I've had, you know, the opportunity to deal with a lot of owners and developers front end of their projects. We commonly get a lot of questions, you know, from them, you know, how am I supposed to approach this? And we're going to kind of go through some things as this presentation unfolds that will, you know, hopefully enlighten you. We're going to go over through, you know, knowing what SIPs are and the benefits of using them as a framing option. We're going to help you understand the meaning of SIP-friendly design. And we're going to identify the benefits of working with an engineer as early as possible in the design process. So we commonly get, you know, engineer record responsibility questions versus SIP engineer responsibility questions. We'll have a slide that kind of goes through that later on. So we're also going to be talking about ways SIP projects can be optimized from an engineer's perspective. There's something that is, you know, classified as deferred submittal when someone's going to obtain their building permit. SIPs oftentimes are deemed a deferred submittal from a building department, kind of like a set of truss drawings. I'll have, you know, Troy will be touching on that a little bit later. So yeah, and then also learning about SIP built structures, project examples. We're kind of going to go through some that I've worked on, that Jeff has worked on in the past, and how engineering and some forethought in the engineering has kind of, you know, helped develop those projects, help save a lot of money in turn. So what are SIPs? SIPs replace traditional wall studs to provide better R value over the entire wall surface. We look at whole wall R value. There's something known as U value that many of you that are on the call are at least aware of. And how we do that, how we increase those values is elimination of lumber, which causes thermal bridging. So a SIP panel is just that. It's OSB skins, foam core, and no studs in the panel. The idea is to use that OSB as a load-bearing element instead of studs. The bearing area provided of a SIP wall is equivalent to 2x10 studs framed at 16" on center. So what we are not is a prefabricated, pre-insulated stud wall. So those exist as well, but SIP panel is a little bit different. The components of a SIP: OSB skins, structural grade laminated adhesive, We have to press the panels for a certain amount of time before we fabricate them, custom fabricate them. You have your EPS core. This cross-section view is showing you electrical chase in there. We get a lot of questions on electrical. And, you know, industry-wide, there's a lot of resources out there. I know from our controls perspective, there's an electrical video that's on YouTube that's a 6-minute watch, and it's really helpful to answer questions on electrical. So components of a SIP. And for further information too on the core material, Big Sky hosts other AIA webinars that, you know, you're welcome to join us on any of them. If you want a little bit more information on expanded polystyrene core and how expanded polystyrene is manufactured, and we're not going to touch on that much today, but just so you know, there's also expanded polystyrene, there's polyurethane core SIPs that are out there. So I wanted to just throw a little plug in there for other AIA opportunities for you guys that are looking for it. And we've got a lot of architects on the call today. We've got structural engineers, builders, owners, developers. We've got, you know, so we're talking to all of you. So we appreciate you joining us. So here's just another view, cross-section view of the components of the SIP. We're seeing a lot more of graphite polystyrene being specified in the core of our material as well. So that white core material is expanded polystyrene, standard expanded polystyrene. The GPS is that gray colored foam. Tests out at a higher R value, so it gives you about an R5 per inch as opposed to the R4 per inch that the standard EPS provides. So that's a little bit about SIPs. I'm going to be handing it back here to Troy to go over the next few things here.
Hey, thanks, Lauren. Yeah, now let's talk a little bit about the structural capacity of SIPs. And it's very, very comparable to stud walls, conventional framing. You look at those things and you say, oh, wow, it's just 2 skins of OSB and in the middle an EPS core, but it's actually comparable in axial load capacity as a bearing wall to stud framing, and it's comparable in bending capacity as well, especially when the wind's blowing against your wall and combined with the axial load. Things like roof panels as well, very comparable to dimensional lumber framing capacities, and shear walls as well. So actually they're even better in shear wall capacity than conventional framing usually, depending on the nailing that you put in there. But when you think about it, you've got 2 layers of 7/16 inch OSB to resist shear loads for your wind shear and seismic loads. So that's pretty great. Also pretty seamless integration of special elements. If you ever have to embed steel columns for whatever reason, knee braces and eyebrows and canopies like that, no problem. There's a way to do that pretty easily. It's also got some other advantages over dimensional lumber, dimensionally stable, meaning that it doesn't twist and warp and check and shrink. You can get them up to lengths of panels are 24 feet long. That's limited by the manufacturing capabilities of the OSB, which 24 feet is the limit of that. So that's a fairly tall wall, fairly long roof panel. That when you think about that, makes construction pretty efficient when you only have to lift a handful of pieces. And then of course, the building will have superior energy efficiency because really there's no thermal breaks inside of the panel, which is pretty cool. And then kind of jumping right into this deferred submittal. Lauren mentioned deferred submittals a little bit back, and you know what that is if you're an engineer of record or an architect, a design professional of record, you can get your drawings to the point where you just specify the SIP wall panels, the SIP roof panels, SIP floor panels in some cases, as designed by others. And so what that does is that you know, if you're going to leave the SIP gravity engineering to a SIP engineering specialist, such as myself, then you don't have to worry about it. You don't have to research it. You don't have to comb through code reports and find that part of the code that talks about SIPs. You can just leave it up to us, and we'll take care of the specifying the SIPs and make sure it's going to support your loads, gravity loads, lateral loads as well. Shear walls, again, you can leave the entire lateral force resisting system design to your SIP specialty engineer, and the details as well. So what that does for you, the advantages are, it's going to take you less time to complete your construction documents if you're the design professional of record. You're going to end up ultimately with a more efficient structural system because your SIP engineer is probably going to have a resume of hundreds of SIP projects, and he's going to know how to get the most out of them. At the end of the day, you're going to have more efficient construction time and a more efficient, energy efficient building as well. So what we're looking at here is, if you're the engineer of record and you defer your SIP submittal, then you're going to look like a genius, Albert Einstein. So jumping right into some of the other benefits of going with this deferred submittal and what we call a SIP-friendly design is there's certain things about SIPs that you want to look for and do. Like for this example right here, you see a detail in the lower right-hand corner. See what we're doing here is we're taking the exterior wall, which is a SIP wall, and hanging the floor joists off of it. So you'll notice that there's no rim board. The joists are a little shorter. Construction time is a little less, and for sure you have less of a thermal bridging through this area of the building, which is pretty cool. There's a lot of other things that we call a SIP-friendly design, including the detailing and the headers and trimmers, king studs, shear walls, all these little things that are basically going to reduce the amount of lumber in your project and increase your energy efficiency, increase your construction time. And jumping right into that, talk a little bit more about the deferred submittals. You don't really need a lot. As a design professional of record, you basically just need simple drawings, a roof framing plan. You might already have your prefab truss layout. This example here is a real project that we engineered as a 1092 duplex project in Butte, Montana. Very bare bones on the drawings. They were given to Big Sky Installations, and their staff drew the panels, so fabrication drawings of the panels. And with those fabrication panels, they were turned over to us, where we engineered the headers and the trimmers and the kings, did the shear wall analysis, and that was it. Not a whole lot of work to do on the design professional of record side of things. And also, just kind of switching gears a little bit, we want to talk a little bit more about SIP-friendly design and some of the tricks of the trade. That's what I call that. And one thing is, of course, you can't forget that the SIP bearing walls need full support at their base. And you can kind of see that in this detail. Whatever your foundation is, whether it's a frost wall or a concrete slab, you got to remember that both the inside skin and the outside skin of the SIP wall have axial or carrying axial loads. So there's going to be some pressure, up to 400 psi of pressure on the bottom of the OSB skin of the panel. So that needs to be fully supported at the foundation with your treated sill and solid bearing underneath of it. So just one thing to keep in mind, a little trick of the trade there. And then kind of another one here that I wanted to share with you is it's pretty neat. This is SIP panels. You can get them 24 feet tall. So we often do two-story tall wall panels, and the way we do that with the floor then is that the floor can be ledgered into the inside face of the panel like that. We call that balloon framing, but it's very simple to do. One thing that we do to accomplish that is we actually drive SIP screws from the outside and screw them into the ledger, which is on the inside like this. And of course, you can see the advantage of that. And there's no thermal break. You're erecting 2 stories at a time instead of 1. So that's pretty great. One more trick of the trade here is that, if you're in a high seismic area or a high wind area, you might need some hold downs, some straps, some brackets to hold the ends of the shear walls down at the foundation. And on the left, you can see what this hold down hardware is, this strap style hold down bracket. And it's pretty simple when you're working with SIP walls. The wall will stand up. We'd have a double stud embedded into the wall, and then the strap just is applied right to the outside face of it and screwed in, and you're done. On the right is we call this a boot style hold down bracket. It's a little less efficient because you have to cut away part of the panel, install it on the inside of the panel, and then replace insulation on the panel, and then replace the OSB as a cover on that panel. So just like a couple of tricks of the trade there for you. Turn it back over to Lauren.
Yeah, thanks, Troy. And Troy, if you don't mind me picking your brain, EOR responsibilities and SIP specialty engineer review, there's sometimes a gray area there that we, as the SIP manufacturer, we try and work our clients through. Engineer responsibilities, engineer a record. They're going to engineer your foundation, any floor system that's not SIP panels, of course. A roof substructure plan generally comes from engineer a record, and lateral design and shear wall schedule and any hold downs, those commonly come to us from an engineer record, right, Troy? And as the SIP specialty engineer, you're hoping for some of that information to come to you. We don't always get it, right? But any further comments on that you'd have to make for our audience here?
Sure. Yeah, absolutely. Yeah, that's true. Engineer record usually specifies their hold down brackets and whatnot. But oftentimes the project doesn't have an engineer of record or an architect of record. And in that case, we as a SIP specialty engineer will just go ahead and do the lateral analysis and specify the shear wall nailing and the hold downs if they end up being necessary. So, because sometimes they don't.
Yeah, and kind of to piggyback off Troy's answer there. So when the concept and the engineering from the engineer of record has been done with SIPs in mind, it really just helps the smoothness of a project. And utilizing the manufacturer's load charts or load design charts, as most of the legitimate manufacturers out there that are in the SIP industry, they've got structural data and that's available to use right when looking at engineering a SIP project. So the additionally, an engineer of record, if they have questions, that's what we're here for as an industry rep. That's also what our engineer partners like Eclipse, if there's some preliminary questions as the design's coming together, some consult on the front end of that structural design, it's a great time to get those questions out there and to us, and we can help facilitate that discussion with a SIP engineer who ultimately would be reviewing your panel drawings. So just some points there. Case study here, Patterson Apartments was a recent project in Colorado that we had done through the Housing Authority over in Grand Junction. So 3 levels to this apartment building, and SIP walls was utilized on all 3 levels. And a very, very unique project. I believe it was 60 units. Yep, 60 units. And the manufacturer in this case was Big Sky Insulations, supplying R-Control SIPs that have the R-Control Max core, which is that GPS foam that we had talked about earlier. So the higher R value foam. Also the panels came with factory installed lumber. So this is something that we're seeing the requests more often to do, where we can't install all the lumber that gets utilized with a SIP install in the factory, because there's horizontal plate material, bottom plate, top plate material that has to be field installed. But we can factory install vertical posting and plating, like corner plating, for instance. What I mean by posting is you might have a king and trimmer detail around an opening where it's headered. So some of those details can be viewed, you know, through the various manufacturers where you've have a headered opening. And so that king and trimmer will come factory installed, and the trimmer cut to size to receive the, you know, the header material. So on this particular project, pre-installed lumber and loose lumber was provided, meaning the plate material and all the other lumber. We don't do a lot of loose lumber packages, but it's, you know, it's something that you want to talk to your manufacturer about the capabilities, what they can provide. And also load sequencing. You know, obviously with an apartment building, there were several truckloads of material. Scheduling out those loads and delivering them took a couple weeks overall, getting all the panels delivered. But the framing time on the walls for this project was pretty impressive. The framing contractor had a good plan in place. All 3 stories was roughly 5 weeks to trusses, meaning all the SIP framing, the floors rolled out, interior framing, interior wall framing as well is included in that 5 weeks. I believe the active SIP framing time just on the SIP assemblies, first level was a couple of days, and same with second and third level. I think there was about 5 to 6 business days on active SIP framing time. So we're, you know, again, the Neopor cord SIPs give an R28 to, you know, to the panel. And so that's a little bit about that Patterson Apartments project.
Yeah, that was a great project, Lauren. Isn't that amazing how fast that goes up? And another thing, just to kind of piggyback on top of that one, Patterson Apartments, the engineer of record contacted us in their design development phase. And I worked with them just to do a cursory review. They were wanting to know whether the SIPs are going to be strong enough to carry the shear load, base shear of the project, and had us do a quick study on the walls, whether they could support the load, the gravity load combined with the wind and whatnot. And sure enough, it worked out just fine. In fact, we were able to reduce quite a bit of lumber just in that first kickoff meeting, and reduce quite a few straps as well. So it was very productive, and the result was less costs and a faster construction time. And one other thing that we ended up doing is on the top story, some of the larger openings, some of the windows, the headers, we only had like 6 inches to work with. And so it was not possible to specify a wood header. So we had to add lib here and go with a steel header. This is a detail that we developed with the engineer of record. It's a W4 by 13, a small steel I-beam. Figured out how to connect it to the trimmer studs and whatnot, and make that work. So just another kind of example of what you can do within the SIPs. You can integrate steel within your SIP project. So that's pretty great. So just kind of wrapping up the deferred submittal discussion, and thinking about what you can do to I guess reduce your design time if you're engineer of record, design professional. Basically get in here just like you would, like Lauren mentioned, prefabricated wood trusses. It's pretty much the same thing. You know, you denote prefab trusses on the plan, just like you would SIP roof panels and wall panels and whatnot. And you basically just get the concept on the construction documents, and you leave the rest of the engineering of the SIPs to the manufacturer, who has their has their own SIP specialty engineers. So faster design time, more efficient use of materials, less materials and labor costs to the owner. And basically, especially in a commercial project, you'll be up and running in less time. So open up your doors, paying less money on finance costs as well. So another case study here, Lauren, house in Lakewood, Colorado.
Yeah, the Branscombe residence in Lakewood, just kind of a side note from the engineering of it. The general contractor on this one, I believe it was 75 or 80%. The blow-in insulation quote that he received was 75 to 80% of the cost of the SIP package, which is significant. You know, it's one of the things, this project was driven, you know, kind of owner driven in the SIP direction. The general contractor had some SIP experience in the past, and the engineer record, this is noteworthy, engineer record, the EOR, it was his first time doing structural design on a SIP project. So he had worked a lot on commercial type of structural design in his career. He's semi-retired, and he, so he actually asked a lot of great front-end questions about roof spans, about loadings on the walls, and how he can achieve what he needed to achieve. So we were consulted, the manufacturer was consulted early on the project. Load design charts were reviewed. Engineer record understood his scope of work, and they're about finishing that project. You know, as we speak, the framing had finished. I believe active framing on this one, you had walls up within about a week and a half, and they were coordinating some of their steel delivery as well as some of that time. I believe their active days framing the SIP walls was only about a week's worth of actual man time. And then roof install just took a couple weeks. Again, they were waiting on some of their steel beam works, so it wasn't a rush job per se to get done right away, but it was, you know, install happened really quick. Contractor was happy, owner was happy. And the Haran ADU, in this, I just want to take a step back, and, you know, I realize that not everyone on this call has probably seen a set of shop drawings. And this is an elevation drawing of one of our set of shops. This is an ADU unit that I've been working on for a client of ours here in Denver. Basically, you're gonna see some of that, like, dotted lines that are vertical all the way up to the top plate. And what those are indicating is it's like a recess in our panel and it's basically every dotted line is a stick of lumber. And so we've got some deep recesses, 4.5 inch, 7 inch recesses that will be filled with solid wood. And the reason why we're showing you this is because as I hand it back to Troy here, he's going to show you the next slide and what some engineering applied did for this project. You know, this, you know, some people will look at this thinking 7 inches, 4.5 inches of straight lumber all the way up. Well, that's not, you know, I'm getting thermal bridging and that posting that you've got called out in the SIPs. But I'll hand it back to Troy and he'll show you what we did with the girt on this one.
Yeah, it was kind of a little bit of a lumber package on this wall. It's open to blow, so it was very tall. And with the wind blowing on the project, we had to figure out how to support that wall. We got a point load ridge right here, and we kind of stepped out of the box a little bit and thought, why don't we just span the structural members horizontally? And so that's what we ended up doing, because it's not as wide as it is tall. And we actually found like a path, a load path horizontally that was continuous, which we really didn't have going vertically. So with one small glue lam girt spanning across the wall about halfway up, we're able to reduce about 300 board feet of Doug for lumber on the project. So that's pretty, this is one of those advantages of having a SIP engineer who's kind of seen a lot of different stuff and might know how to optimize your project a little bit. Moving a little more quickly now, just kind of want to show a couple other case studies. There's a roof project in Bend, Oregon, one-story house, SIP roofs the whole way. And really the only question that kind of came up for discussing during the design phase was, how are we going to support this chimney? Big chimneys on the project, 3 of them, and they had stone on the outside too. Pretty cool architectural look, but it's kind of heavy. And question is, well, what should we do here? I mean, is it easier to frame the SIPs around the chimney wall? Or what we ended up doing is talking to the manufacturer. It turns out that we could simply embed lumber inside of the roof panels. And you're looking at a plan view of some of the shop, just a portion of the shop drawings right by the chimney. And the outline of the chimney is right here. What we ended up doing is the panels came to the site with the lumber embedded into it, so they could just fly the panels onto the roof, screw them down, and then start stacking the upper portion of the chimney on top of the embedded lumber, just like that. And then kind of turn it back over to Lauren, another project down there in Colorado.
Yeah, and Eclipse did the engineer record work on this project. Gabler Apartments, 6.5-inch thick SIP walls, 10.25-inch thick SIP roof. Nice design. The developer on this, has some SIP experience, and so in his design, it was already kind of in his mind to try and optimize SIPs, and from the design phase. So it did. Troy will be able to comment further on that when he talks more about it, but I believe it kind of helped from his standpoint of being the engineer of record and also reviewing panel drawings. But developer, the feedback on this, tenants have been thrilled with the high efficiency of the units. Each unit is beyond 1,400 square foot. There's 6 apartments in this building. So it's not one of those giant multifamilies, but the tenant's electrical is $18-20 a month. Gas is $28 to $30 a month, significantly lower than most of the front range. I can tell you, I think more often than not, people are paying double that at least. Depends on the size of units, of course, and how efficient, any apartment anyone lives in. But active framing time for the SIP walls was about 4 to 5 working days, because they spent about 2 days on the first floor, and the second floor was done, I think, in 5 hours. And the third floor, the further you go up, the more, precautions you take with bracing and stuff. So I think that third floor took them about 1 to 2 days. And then the roof was on in a matter of hours. They had a crane on site for 1 day, and I think it took 6 hours or so to set this roof. So it gives you a little insight on speed of construction. This project also had that plate height and the hanging floor joists off of that taller plate height on the detail that Troy had showed earlier. And I think he's going to show it again. But that's really a nice detail. The builder on site, the framer on site, doesn't have to come in with joist plugs and plug all those joist locations. I'm talking when a floor system is stacked on top of a plate to go multi-level. So really, worked pretty slick on this one.
Yeah, pretty sweet project. And just wanted to kind of show a little bit more of the drawings on that. So this is an isometric view that this produced by Big Sky Insulations. Premier does the same thing, where you get a 3-dimensional view of the panels of the project, and you can kind of see here Gabler Apartments. It's almost all SIPs. The floors are not SIPs, but you can see the roof, you can see the walls, 3 stories of SIPs. And you can kind of see that another thing that really what we produce, we were the engineer of record on this as well. And this, you can kind of see how simple our roof framing plan is. It's big and clean, and there's only a half a dozen details cut on the project. We just basically specify 10-inch roof SIP panels across the whole thing, show the bearing walls, and then the rest of it is going to be drawn up by Big Sky Installations. And this is it. This is what they ended up with. So you see the roof plane like this. You can kind of see the panels, and it's very optimized. They're 8 foot wide, and the green lines are the outline of the panel. A little bit over 20 feet long, this one, and all of them along this side. You can kind of count them. There must be, I don't know, 24 panels on the whole thing, and it goes up very fast and very smoothly as well. This is a drawing. It's an elevation drawing of the panels. You can see where the splines, the interface between panels, occurs. This is not like the final fabrication drawing, but it's a schematic of where the panels lay out on that south elevation, the tall elevation. You can see how simple and easy it is as compared to a stud frame project. And you know, there's some more final pictures, a construction photo right here, and pretty cool, very successful, and lots and lots of SIPs in that project. Very cool. So just want to kind of just do one more case study and just kind of tie off on the discussion about the benefits of SIP-friendly design. Kind of talked about these earlier, but again, less work for the EOR, shorter design phase, achieve taller walls with less lumber, fewer beams, headers, and columns. The shear walls are going to have less lumber, less panel edges, less nailing. Connections are standardized. It's more simple. In fact, your detailing can be left to the shop drawing phase. You just basically defer that portion of it as well. Construction phase is going to be absolutely way shorter. Less questions from the field too. That's one of the things that I noticed from decades of being an engineer of record, is that I get far less questions from the field. It just seems like everything is super coordinated and super thought out ahead of time, and the panels go up without many questions ever. And of course, a more efficient structural system and construction time, of course. So just another case study here real quick. This is a 4-story apartment complex in Wenatchee, Washington, the Wenatchee Supportive Housing. Very large project, and lots of advantages for going with SIPs on this project too. But I wanted to kind of get into the detailing of it just a little bit. And one of the things about going with SIPs is that, you know, what are you going to do with shaft walls and ledgers on your shaft walls? There's, of course, to get into a project this big, you're going to have area separation, walls and whatnot. You're talking 2 or 3 layers of gypboard on the top of your bearing walls, and that gets to be a little bit of a challenge sometimes if you've got elevators and stair shafts. So what we're able to do is literally just embed lumber into the panels, and then we're able to attach things to that. Things like intermediate landings for stairs and handrails and whatever else has to be attached to that. So Wenatchee Supportive Housing, here's this detail again where we went with the, it's not really balloon framing, but it's stack framing, but we avoid using a rim, and we have less thermal braking, less labor, it goes super fast. Everybody ends up being super happy with details like that. Another one, here's that embedded lumber piece again that we put inside the panel to attach the floors to, and intermediate stair landings and whatnot. Lots of ways to make things happen. And here's another one. This is kind of like the ultimate coordination element right here on the ends of the building. The architect has brick veneer. So, and it's a tall building, 4 stories. And if you're a design professional, you might know that you have to have a relief angle for your veneer at 30 feet above the foundation. Well, you know, mortar joints are 2 1/3 inch on center for standard brick, and we really wanted to work with the design professional, the architect, to make sure that the relief angle was going to be placed at a point where you could screw it into some lumber. And so we calculated and specified some options for him, and that got done. In fact, I think it got done. I didn't get any calls from the field, so it must have went perfectly. A few more details here: just embedded lumber, wall ties, and brick ledgers. Everything can be coordinated. It's just a matter of communication between the design professional and ourselves. So just one success story after another. Another real quick case study is the 7-Eleven project in 5 Washington. Super simple 1-story commercial building, and it's kind of, it's just one of those things where everything just was perfect to utilize SIPs and the advantages of SIP panels and panelized construction. It's literally just bar joists at 8 feet on center, spanning the short distance across the building. Roof panels laid on top of that. So you can imagine the SIPs come in 24 foot, you manufacture them 24 feet long. So we had those span over three spaces of the bar joists and screwed them down directly into the bar joists. So I'll show you detail on that in a second. But the walls, it's kind of the same thing. You can see each one of these wall panels is 8 feet wide. It passes balloon frame style, passes right by the roof SIPs and forms the parapet on the building. So pretty sweet. Not really sure how long it took to build it. Probably not very long, just a matter of days. And here's that detail on the roof connection to the bar joist, the steel bar joist. They actually make SIP screws now. They're self-drilling screws. You can drill right through the double top cord of the steel bar joist. So pretty efficient. Saving lots of lumber on that. Normally you might think, oh wow, I have to put a wood, just a wood piece carriage bolted down to the top of the bar joist and then SIP screw into that. But nope, we now have screws that can penetrate right through the steel. So another case study project, one in Denver, Lauren's going to talk about.
Yeah, South Washington here. Developer has an engineering background, had an interest in SIP from the get-go. So there were a few things that they wanted to accomplish with this, right? On the front end of the project, they wanted to build a very thermal efficient envelope, and they wanted speed of construction, a quick speed of construction time frame on this. And ultimately what happened is, just that. You see a couple of the photos in framing mode there. Those were taken during assembly. I think you had first walls up within a day, I think it took, and then after that second floor was rolled, second level walls were up within a couple of days, and the roof assembly went very quick. I believe it was about a day and a half's worth of hoisting roof panels into position. So obviously SIPs are just one of the framing elements on the job site. You get your floor system, you've got some beam work to put in there. You see in that picture in the lower right, some beam work to go in before roof panels are hoisted into place. So really neat project to kind of see go up start to finish. The engineer of record on this one did not have previous SIP experience, or I should say they didn't have a ton of SIP exposure. The SIP manufacturer was consulted early and often regarding load design charts on this one. So and then Jeff's going to take us home here, I believe, with a few of his project profiles.
Yeah, I got 3 commercial projects that we can look at where the engineer that engineered these projects, he knew the SIPs very well, and they helped save quite a bit on time and money. The first one is this Wenatchee Elementary School. It's in Vegas. And when we went to meet with the school district, they were using masonry and concrete tilt-up typically on their schools. But at that time, there was estimated construction costs were rising due to market conditions, and there was rapidly rising energy costs. So we talked them into giving SIPs a shot, got the engineer involved, and you could read all these particulars, but they lowered the cooling costs by about 70% compared to other schools in the district. And because of the engineering and the use of SIPs, they reduced the drying time by about 60%, and which accounted to about $2 million in total construction costs. Just removing steel, and again, not all the steel, but a lot of the steel, and just using the SIPs. This is a 3-story commercial project in Porterville, California. This is a quick time lapse I'll run through. They use SIPs for the exterior walls, the intermediate floors, and the roof. Okay, here's the information about the project. 50,000 square feet, as I mentioned, 3 stories. Because of the engineer that engineered this and the use of SIPs, the reduced substructure, a lot of steel removed, moment frames removed. Due to the panel floor spans, fewer steel beams required, and reduced hardware, hold down straps, etc. And with the use of SIPs and the proper engineering, reduced framing schedule 5 to 6 weeks. And it was a prevailing wage job, paying about $1,500 per day in labor. And lastly, Walk-Ons is a restaurant. The founders are actually a couple of LSU basketball walk-ons. They were unrecruited and unsigned. And while on the team, they recognized the need for a sports bar near the campus. Since they spent most of their time sitting at the end of the bench, they had nothing else to do, I guess. But they both had a vision for a business environment where everyone on the team was needed and mattered as much as the next guy. And they eventually opened a bistro and bar in the shadows of LSU's Tiger Stadium. But they've used SIPs on a few of these, and they were able to meet the architect's vision while removing the steel. Because you can see those pop outs and stuff, the original designs, there's a lot of steel involved, but the engineer removed most of that by using SIPs. And again, a reduced framing schedule and less hardware. In this particular project right here was in the Texas coast area.
Yeah, those are some really good project profiles there, Jeff, and I'm glad that we were able to feature some of them. On that cornerstone project, utilizing SIP floors internal to structures, it's not something we commonly see, but on that project, what was the main driver? Was it the speed element, or can you share a little bit more about that?
Yeah, and Brian's on here, the engineer that was involved in it, but it was more speed and just so they can space the beams out farther, reduce the amount of steel needed on the project. So yeah, you're right. Typically, they do not use SIPs for intermediate floors, but on this one they did for mainly those reasons, to remove steel and put the floor down quicker.
And big time reduction on labor. Those labor costs are incredible, the cost savings on a project of that size. So
Right.
Yeah, thanks for sharing that. So yeah, I'm just gonna kind of help moderate the Q&A section of the end of our presentation here. So first of all, just wanted to thank all of you for spending an hour with us, and you're all welcome to hang on for Q&A. We've got 13 open questions here that I'm gonna try and go through in an efficient manner, and we've got panelists, more panelists than just the presenters here. So we've got kind of a mind of many SIP experts. So you guys can chime in too if you've got some additional comments to make. But Pedro asks, do you have typical details for side framing of SIP panels to LVL beams, meaning SIP framing to the side of LVLs? Troy, maybe that's a good one for you, but side framing of SIP panels to LVL beams, what I'm thinking he's meaning is, like, do we cut, like, is there like a beam pocket? And Pedro, if you're asking about beam pockets, certainly that's something that, a SIP manufacturer can help you with. Some SIP manufacturers will cut that beam pocket. Others will, encourage, some of our contractors would rather field cut a beam pocket just so they can make sure it's cut to the exact size that beam is going to come in at. But SIP framing to LVL beams is my assumption of what your question is meaning, but also framing SIPs onto interior framing. There's details on how to accomplish that, and so I hope we answered your question, Pedro. If you need any further clarification, feel free to type in a follow-up question. And Adam is asking, how are wall to floor details modified to handle electrical runs and maintain efficiency? What are options to use foam splines to reduce bridging, as in many locations as allowed? So good question. Jeff, do you want to talk about floor to wall electrical runs?
Yeah, I know when we do our shop drawings, they actually show where every electrical chase is going to go in the shop drawings. So if they need to be moved around, they can be, and then we can, fabricate according to your need without turning the panel into too much of a, Swiss cheese. You can't just throw chases everywhere, but we have limitations. But again, we can lay it out on the drawings, and you can move them around accordingly. And as far as foam splines, that's basically dictated by spans and loads, especially on roofs and floors. But typically we'll use the what you call the foam spline, which is a super spline, 2 skins of OSB with a foam core, just like a SIP, as the connection, unless, again, it can't be used because of spans or loads. And then we go to the other connections, which are I-joist and or lumber connections, last resort.
Yeah, very good. Yeah, thanks, Jeff. Kevin asks, ESR 4524 table 11. He must have been digging in some of our published data. And Troy, so Troy might be a good one for you. Diaphragms. Footnote number 2 states interior support shall be spaced not to exceed 12 foot on center. Does this mean that the EOR shall locate beams at 12 foot on center max if diaphragm action is needed, assuming SIP design will be a deferred submittal?
Yeah, that's a really good question, and I've talked to the authors of the ESR reports about that because it comes up a lot. And their answer to me is basically, Troy, just go ahead and use your engineering judgment. So we do. So we take maybe we take a little bit of a reduction on the capacities of the diaphragm when we're spanning them farther than 12 feet. Or we just use the National Design Specification, the design manual for wood, and look at the nail spacing and the edge spacing and whatnot, and use the values out of that. So it's not a big deal. You can definitely span your supports farther apart than 12 feet.
And Troy, another one probably. Kevin is asking, the PBS design manual table 1 shows a dark line for max recommended roof spans. but these appear to be considerably less than what the allowable loads state. For example, 11¼ inch core panel, max recommended span is 16 foot, but allowable load for a 20-foot span at L/240 is 39 pounds per square foot. Can you elaborate on this dark line max recommended span? And can the 16-foot span even be used if diaphragm action is required?
Yeah, another great question, Kevin. I think we answered the diaphragm question, and the dark line is it's sort of just a rule of thumb, sort of a guideline for people that aren't super familiar. If you're not a specialist with SIP design, then that's sort of a limit so you don't get in trouble. But the reality is that, yeah, we can span farther than that. It kind of depends on the finishes and whatnot, because the code, the International Building Code, puts limits on the maximum deflection on your roof members. And so it really kind of depends what you're hanging off of there, what your finishes are. Do you have plaster? Do you have drywall? Do you have wood? And the other thing that we get into is the long-term deflection properties of SIP panels. They're similar to wood, where if you have a long-term load on there, then there's going to be a little bit of a creep factor on your wood. And so we would have to actually dig into it, sharpen our pencil, know what the dead load on the assembly is, as well as the live load, before we want to exceed that dark line. But we do it all the time.
So I'm going to take actually a step back. There were a couple questions that I had typed in answers. Audrey had typed a question about global warming potential score. So you guys that are attending, I think everyone can see the answered portion of these questions, but I gave a link to a nice piece of literature that goes over some of the life cycle analysis that has been done. And then Luis had asked about fireproofing with SIP. So many manufacturers SIPs can obtain a 1-hour fire assembly if the manufacturer has the code report to explain how to obtain that 1-hour assembly. So there's differing levels of fire code requirements, and so you want to consult your manufacturer's code report on how to obtain those. So thanks for the question, Luis. Adam is asking, are there clever details to thin up the edge details where R value is not required in an overhang or non-conditioned space? He's asking, can you layer one SIP on another? What needs to be considered regarding dew points and surfaces that might get damp? So Adam, just, I'll try and be brief. Oftentimes if you don't want the thick fascia of a SIP overhang element of the roof, some design will call for us stopping that roof panel right at the outside wall line, and you can ladder frame an overhang that's thinner, if you will. So ladder framing can be done lots of ways. You can attach it to subfascia, and that would have to be engineered. You'd have to, depending on what your loads are, where the project is located, it gets engineered accordingly. So that's what we see most often. Occasionally, depending on the manufacturer and what their capabilities are, sometimes we can have members that backspan up into the panel where you can thin up that fascia line. And so the members can run proud to the edge of the SIP panel that's overhanging, and that's how to accomplish that. So, further questions or follow-up questions, absolutely feel free to reach out to one of our guys in your location, and we can get with you further on that. So thanks for the question. So Steve is asking, can we touch on future possibility of pre-assembled panels? And absolutely, Steve. I mean, that's something that it's a manufacturer by manufacturer type of question, and based on their capabilities. I know in my experience, Big Sky, we're seeing more of that lumber install that we had talked about earlier in the presentation getting specified. There is some discussion on, future possibility of furthering our RTA capabilities, RTA meaning ready to assemble. for instance, like window openings, like trying to combine headered window opening locations where we can and where it makes sense to in the factory. You know, we're always open to trying to press the boundaries there. As of right now, we don't have too much of that capability. I'm talking from the Big Sky perspective. I believe Premier has done some of that. We've done some of that as well. But we also want to do it in a way where when panels ship, you've got some panel seams now that you're creating, and once those panels hit the job site, you know, we don't want the contractor not knowing panels are assembled and having a seam and having issues with that flexion at the seam. So anyways, those are just some things we're always trying to kind of further our ability there from an RTA standpoint, because we know labor's at a premium out there in the field, and the more we can assemble, the more we can do in the factory can tend to help. So that's a good question, and one that we're always trying to work on. So we'll be in touch about that. Kevin asking a question, this might be good for you, Troy. ESR Table 4, Type L spline, footnote 1 states that spline shall be spaced not less than 4 foot on center. However, panel widths appear to come in 8 foot widths. Does using lumber splines automatically restrict panel width to 4 foot? And actually, Troy, it might be, I might be able to help here. Sometimes Kevin will be able to factory install members where it makes sense to keep that 4 foot on center detail going. Like if it's an I-beam, a roof that has I-beams in it, to obtain that 4 foot on center, we can factory embed an I-beam. I know Premier's got this capability when they lay up panels. Big Skies has this capability. You want to check with your panel manufacturer on the capabilities, but some manufacturers are limited to 4 foot widths anyways.
But that, Lauren, that particular table is saying that, as far as I know, I'm not an engineer, but when we have to use lumber splines on roof or floor panels or I-joist splines, they are limited. They have to be every 4 foot. You're right, they can be embedded, and so you can use an 8 foot wide panel, but they have to be embedded every 4 foot. The spline connection does not. Then you can use the 8 foot wide panels, but if you have to use the lumber or splines, they have to be every 4 foot. That's as far as we understand, but Troy can answer that too.
Yeah, sure. Yeah, that's absolutely correct. And in that particular table, the values that you see in the table are based on your lumber spline at 4 feet on center. So now there's a lot of different things we can do too. There's alternate means and methods and higher order analysis that we can do as engineers. And we could put lumber at 8 feet on center and get a value out of it that would be somewhere between the tables you see and the foam spline tables. We could also, if we needed to, we could go even one step above that. If let's say that you're in such a high snow load area, say way up in the mountains, and the lumber spline doesn't seem to give you the capacity you need, we can use LVLs. We can space I-joists at 2 feet on center or 16 inches on center and come up with a capacity for that through higher order analysis and formulas that we have available to us.
Yeah, thanks. Thanks, Troy and Jeff. That's good stuff. So there's a question I want to get to: how internal and external building envelope requirements are met using SIPs, like vapor and air barrier requirements. So just a quick response on that. So technically, a SIP will classify as a class 2 vapor barrier, vapor retarder is the technical code word that we like to use. And air barrier, it also classifies as an air barrier. Now in a wall application, still by code, you still need to apply WRB, weather resistant barrier or water resistant barrier, if you will. And so in a wall application, that's still by code, you still need that, but hopefully that answers your question. And this one here, EOR versus SIP engineer, do you at Eclipse prefer to handle both parts or just consult with SIPs, ESP with smaller and residential projects?
Well, we can do either one. I've got a large stable of engineers, and they enjoy being just the SIP specialty engineer. And we do a lot of projects where we're the engineer of record, and also the SIP specialty engineer. So it doesn't really matter. We'll negotiate a fee for doing either one, and we're got a lot of experience doing either approach.
Okay. Is it common to have SIP roof panels with built-in 2x10s at given spacing for heavy load requirements? Pedro, good question. So it just depends on the design criteria, project location. So we look at a roof design with SIPs, and we look at the spans, and then we either have I-beams in that roof system, or we have, if the spans of just the raw panel can accomplish what we're looking at, that's our go-to. But then if need be, we commonly don't see 2x material embedded in a SIP panel, but we can do LVL. We can do this custom sized I-beam that a lot of manufacturers will utilize. Not all manufacturers use it, but I know Premier and Big Sky do the I-beams at a 4-foot center spacing that, help reduce that thermal bridging. And a 4-foot on center spacing is not much thermal bridging in that roof system to help accomplish further span. So that's, we see that often. Talk about SIP use for floor to ceiling situations. What about decks and overhangs, especially over interior spaces as compared to traditional framings? Also, how do SIPs work in cantilever situations? Rules of thumb for design. You want to handle that, Troy?
Sure, yeah, absolutely. Okay, so there's a few questions in there. The cantilever situation, we have some tables. Manufacturers have some tables of what your maximum cantilevers can be and their respective loads. So that's definitely a thing, and it's available. Yeah, as far as like using as a deck over an interior space, well, I mean, you're going to have that same challenge whether you're making that out of engineered lumber, dimensional lumber, or SIPs. You just have to waterproof it properly and make sure that moisture cannot get into the floor framing. So yes, and it depends on the spans, of course, and the loads. And was there a third question in there too, Lauren?
Just, yeah, rules of thumb for design. I think where David's going to find those, is in the load charts and in the tech bulletins about overhangs and cantilevers. If it's an unsupported cant, which I believe is what he's asking about. So there's some technical bulletin information about that. And then, our Big Sky, I can speak from Big Sky's perspective, our tech bulletins don't go beyond 4 foot of unsupported cants. Can we go beyond that? Absolutely. And then that's where it comes down to the SIP engineer, what they're comfortable with. Sometimes we might just need some additional members to accomplish a further design. And those members have a backspan into the main roof panel plane, so there are some rules of thumb for design. Absolutely. And just, contact one of us directly, David, if you need help finding it. I know in Big Sky's website, it's in the technical bulletin section of our,
and Lauren, Premier's it is too, but our chart is, we have a 6-foot max cantilever with a 12-foot backspan if you use a certain connection. So
perfect. Yeah.
And just one more thing on that one, Lauren, is that there's a lot of weird situations that we run into with building design, cantilevers, and all kinds of stuff. And if you get into a situation, or you're the design professional, you get into a situation and you just kind of don't know, just contact us either through Lauren or just directly, and we'll do a cursory review on that and tell you what we can do to make it possible.
Yeah, and Anthony's asking about SIP's use in floors. I thought on an earlier project they did not. Is this discretionary? Anthony, really just comes down to, Jeff featured a project where they used SIP floors internal to that structure. It can help save from a speed of construction element. If you're conditioning separate floors, different from one another, it can absolutely and should be considered. SIP floors when they're internal to the structure, we don't see them often just because they're not conditioning those spaces separately. So conventional floors are often used, and that's, so that is totally up to the owner, developer, and designer of the project. So Compliance, David's asking about compliance with new energy codes in Washington State. And David, you'll find some of that information that you're seeking in the NTA report that Premier has. And what IRC and IBC that our code report adheres to. But I'd encourage you to connect with your local rep there to discuss, because I don't know the energy codes in Washington State specifically, but yeah, you'd want to connect with your rep and just make sure that you're meeting code requirements.
If Pedro's meaning, we already talked about that question, but if he's meaning like post and beam, that might be what he's talking about too, so they can be attached to the outside of like an LVL structure. And then I'm sure there's details out there for that. Otherwise, I think Lauren answered the question about pocketing and all the other stuff. So
yeah, thanks, Jeff. And I figured Pedro might have another meaning to it. So yeah, you can absolutely we can pocket out the core of the SIP and have SIP walls meeting at a joint and surrounding and enclosing column work in a wall system, or that if that column is inside and it's like a timber frame or post and beam type of construction, we can plan for the SIPs to run by it on the outside to complete your envelope. There's lots of different ways to approach that. So hopefully we're getting to your question there, Pedro. Where can I get the RSI calculation for design purposes? And RSI calculation, little help on that, Troy or Jeff? I'm not sure.
I'm not sure what RSI stands for. Is that is that for insulation purposes or values? I don't know.
Yeah, I'm not sure, but yeah, if it is an RSI calculation,
I think it's relative straight index, but I'm not sure how to get the calculation that he wants. I think there's calculators out there for it, but I don't know. I'm not, I don't know.
Yeah. So Nabil, if you want to contact one of us, after this to help, it's the thermal insulation. So I'm thinking maybe it's like R value or like a U value calc. We have technical information on, R values and U values. So the R value charts are published, and Nabil, I'll get you, I'm going to type in, where you can access R value charts, so that you can see the R value. Obviously, the thinner panels start at the smaller R values. We have an R16 panel all the way up to an R48 panel, all the way up to an R58 panel, matter of fact. And I think Premier can even go thicker than that. So just kind of depends, on the local R value requirements. And this is a side note, I have done jobs at certain jurisdictions. They will know that it's SIP, and R value requirements will sometimes drop from an R49 in a roof, and they'll drop that requirement to an R38 because SIPs might be classified as continuous insulation in their mind. So CI requirements might bring that down. So you want to check with your local requirements, and if you're incorporating SIP in your design, it's something to consider there. So. Would a SIP panel on the narrower end, 4.5 inches, for example, be feasible for exterior bearing walls on typical 2-story single-family residence? Maybe good one for you, Jeff. We see a lot of 6.5 inch, Luis, as exterior wall applications, especially when we go 2-story for structural needs, and also R value needs. But Jeff, do you have any further comment on that?
Can you hear me?
Yeah.
That's really up to engineering. I think I don't think I've ever done a 2-story SIP project with 4-inch walls. They've all been 6 or more. So I'm not saying it can't be done. It's probably more of an engineering question though.
Yeah, I think it's possible. It's possible. The axial load capacity of a 4-inch wall panel is pretty close to a 6. The bending capacity when the wind blows against it is a little less. So it would just kind of depend where you're at. You know, if you're in the urban area where the wind exposure coefficients are small, then you've got a great chance of making that work. If you're out on the ocean and you're exposed to hurricanes and whatnot, then probably not.
Yeah, very good. Ross is asking, makes a lot of sense for larger commercial projects, but what about smaller residential? I call it the IKEA factor. It seems like it's a lot easier to buy and transport a trailer of 2x4 and building material than to move an entire wall over the road and then install with conventional tools and methods. So, you know, Ross, great comment and question there. It does make a lot of sense for large commercial projects. We do see a lot of residential work as well. You might be surprised. And so sometimes it comes down to certain things, you know, that what are you trying to accomplish? Are you trying to build thermal efficiently? First off, is, you know, there's a lot of builders that want to build a structure for, you know, they have goals in mind, whether it's thermal efficiency, a budget that they have to stay under. Right now, with the price of 2x material being so high, we're seeing kind of an uptick in opportunities because SIPs make a cost viable option. We're always competitive with conventional framing, but right now with prices of other materials, it's making that so much more. So, you know, just depends on the goals. You know, if someone wants to build efficiently and it's a wood framing structure, whether it's walls and roof application or both, SIPs could definitely be in the conversation. So from a speed of construction element to the, you know, if the owner's living in this house or structure for 30 years, what they want to see out of their energy bills in the future. So yeah, it's a really good question. It's one that, you know, we understand that SIPs isn't a solution on every project. We don't mind saying that, but certainly when wood framing is involved, it can definitely be in the discussion. So
I'm actually seeing, Lauren, I'm actually seeing at least one even small like ADU a week right now, people wanting pricing for or taking delivery of. So
yeah,
it doesn't have to be a big project. It can be anything pretty much.
We've done tiny homes, ADUs, garages, outbuildings. I mean, big commercial projects, multifamily, as you saw, you know, so really the whole gamut, you know, can be framed in SIP. So Ross is asking also regarding installation. Every GC knows how to build a 5.5, you know, 2x6 stud wall, but is much training required for these, meaning SIP panels? And great question. So, you know, we're part of that training, being affiliated with a SIP manufacturer. We can help train you. There's resources online. There's classes that you can take. There's we don't endorse everything that's out there on YouTube because there's a lot of craziness out there on YouTube, but some of the manufacturers will have some manufacturer made, you know, YouTube content that kind of helps train people on the material. And also, you know, shop drawing review, being involved with your SIP your SIPs representative when you're going through shop drawings and educating yourself on our details and construction details. So yeah, that's what we're here for. There's other resources for you, Ross, too. And so contact us if you want to get access to some of those things. So Mary, we will connect with you, Mary. I'll have Lori touch base with you about getting you AIA credit. So thanks for typing in that note. Also regarding demolition, is this insulation in particular, no pun intended, the graphite impregnated type, a particular hazard or otherwise regulated in quality? No, it's not a hazard. As a matter of fact, EPS is non-hazardous. Ross, if you want to join us on one of our other AIA webinars, we can talk about EPS in great detail and how we make it and how it gets used. And but yeah, basically the raw material, how it's made is just EPS pellets that are like grains of sand, right? And then you hit it with steam. It's all it is hot air and steam that expands it. It's why it's called expanded polystyrene. And then we mold it, right? So there's no off-gassing that happens because it's just made with air. There's no R-value enhanced blowing agent. Some other rigid foams are made that way, that eventually they off-gas and they lose some R-value. That's why 90% of SIPs made in North America are EPS or GPS cores. So, as a drafter, are these walls dimensionally similar to stud walls? So as a drafter, Troy, you may have some comments. The only thing that's different when you draw a SIP wall is your exterior skin, the exterior sheathing on conventional framing can be overhung, whereas your bottom plate on SIPs is set back a ½ inch so that we get full bearing on the platform, whether it's you know, up a slab or a floor platform. The bottom plate is set back a ½ inch so that exterior skin is load bearing. That's part of your structure. So that's a great question, technical question, and you can view some of our details with cross-section wall views to, you know, get a visual for what I'm saying.
And if you're drawing a say a 2x6 wall, typically it's 5.5 inches, where a 6-inch panel, we call a 6-inch panel 6.5 inch finish. So you got an inch difference there, basically. That's just something to keep in mind.
Yeah, thanks. Yeah. Pedro is asking for a SIP rep in the greater Boston area. So Pedro will connect with you offline here. Pat is asking, will SIPs tend to expand and contract more so over stick frame construction? I built a SIP home 16 years ago in Belgrade using their system for walls and roof. Every spring I hear my roof cracking. So Pat, that's something that will happen with SIP assemblies occasionally. It does not happen every time. That popping, Jeff might be able to expand on this, but sometimes that popping has to do with the temperature of the roof. And when material, any building material, when it expands and contracts based on temperature, it could be a temperature change from, you know, the sun coming up in the morning or the sun going down in the evening. That will happen at a panel seam or a joint. It's all it is the material moves a little bit and you can kind of hear a pop. So I've heard it myself. So I know exactly what you're talking about. And if you have any concerns, you can absolutely contact your local representative. So
The only time I really seen the issue was in Palm Springs, where it got hot, and we found out they didn't put enough screws in the roof panels. So when they went back and re-screwed the panels down to the beams, it stopped. But that's the only time I've dealt with it.
okay, and we'll try and be real brief here. We want to get this wrapped up in respect for everyone's time. Pedro is asking, is it possible to have roof SIPs built with 2x10s at 2 foot on center instead of the double 2x10 at 4 foot on center? The answer is yes, Pedro. We can do more of a hybrid type of panel and contact your representative directly for you know, details on that. Not a lot of us have those details like published, but we can absolutely make more of like a hybrid panel that has, you know, LVLs at a tighter spacing. David's asking, how do SIP walls and floors perform for sound control in multi-tenant or a multifamily construction? SIP has a high STC rating. That's a sound rating that's been tested for. So there's absolutely STC data that we have published that you can check out. Our websites have that information, or David, you can contact your local rep to get that information. I'm actually I'll type you a link here so that you have it. And then I think we've answered everyone's questions. So is there, I guess at this point, we still have some folks on the call. So we sure appreciate everyone's time and attention and all the questions. Certainly big thanks to Troy and Jeff being on this call with me, and Lori helping set it up. Lori, did you have any closing comments?
Yeah, I just wanted to let everyone know that we'll be sending links to the websites with the BIM information and the load charts. And we'll also be sending your certificates and a recording of the session today. And thank you all so much.
Thanks, everybody. It was a pleasure.
All right, bye now.